Okay, so on notes 9-2, we're going to be looking at rational exponents. What rational means is that you have a fraction. So we've already talked about laws of exponents. Now we're going to be looking at fractions that are exponents. Okay, the definition, whenever you're trying to evaluate a base that has a rational exponent, there's a way that you can change it to a radical and evaluate it. Okay, so the definition tells us right here, b is going to be your base, p is your power or exponent, and then the q represents the index. So remember, the index is what root you're taking, square root, cube root, fourth root, so on. Okay? All right, so if you have a base that has a rational exponent, you can change it and write it as a radical. How you would do that is your base becomes your radicand, which is the term under the radical, and then your p is your power, your exponent, and then q is your index. Okay? Now, it can be written as this one here, or you can put parentheses and put that power on the outside, which in a few minutes when we evaluate, that's going to be the easiest way to do it. Okay? All right, so these first couple of examples, we're just going to rewrite each expression using rational, which is fractional exponents. Okay, so I'm going to rewrite it. So whatever your radicand is, which is the term under the radical, will be your base. So our radicand is 8, so our base is 8. And then our power, which is our exponent, notice there's not 1, so that's a 1. And our index is not written there, but we know that's a square root, so you could write a 2 there. So the square root of 8 means the same thing as 8 to the 1/2 power. So from here on out, anytime you have a base to the 1/2 power, that means you're going to take the square root of that base. Okay? All right, so let's look at 2. So our radicand is 5, so that's our base. Our exponent is 8, that goes on top, over our index, which is 3. So the cube root of 5 to the 8th power equals 5 to the 8/3 power. Okay, so looking at 3, notice this time that our radicand, which is the term under the radical, is 3 and x. So you're going to have to put parentheses around both of them. So that way the entire base is 3x and not just x. So make sure if there's more than one under the radical that you put parentheses around it. Our exponent, notice they wrote it a different way, but our exponent's on the outside. That's 3 over the index, which would be 4. Okay, so now we're going to do the opposite. We're given the rational exponent. We're going to change it to radical notation. Radicals we talked about on 9-1. That's a square root, a cube root, a fourth root. That's what radical means. All right, so our base, whatever our base is, will be our radicand, which is the term under the radical. So I'm going to go ahead and draw my radical and put 4. The exponent is 1, so I don't have to put that. And the index is 5. So that's 4 to the 1/5 power means the 5th root of 4. So anytime that top number of your rational exponent is a 1, that means you're either going to be taking the square root, the cube root, the 4th root, or 5th root, because that exponent would just be a 1. So if I had like 2 to the 1/3, that would mean I'm taking the cube root of 2. If I had 4 to the 1/4, that would mean I'm taking the 4th root of 4. So anytime that top number is 1, you're just taking that root, whatever your index is of that number. Okay, so 5, the base is 16, so that goes under the radical. The 5 is your exponent, and then, so you can either put it here, or you can put it on the outside of your parentheses, and then your index is that bottom, so you're taking the cube root. So either of those, it's the same thing. But once we get to evaluating, you're going to like this way much better. Makes it easier. Okay, so notice that 6, our base is in parentheses. That's 5xy squared. All of that will be your radicand, which is the term under the radical. All of that. So put parentheses around it. Your exponent's going to be 3, so you can either write it under the radical or on the outside. and then your index is 4, so you're taking the 4th root. So either one, it's the same exact answer when you evaluate. All right, so the next part we're going to actually get into evaluating, which means we're going to be finding a number answer, okay? So anytime you have a base that is a number raised to a rational exponent, which is also a number, you will actually find that, so you will evaluate it. We're not going to be using the calculator, we're just going to be rewriting it as a radical, which we just talked about. So my base is 4, so that's the number that goes under the radical. When you're evaluating that exponent, which is the top number of that fraction, it's easier if you put that on the outside of the parentheses. And the index is 2, which means we're taking the square root. You don't have to write that because the square root, we don't have that index written, but you can if you want. Okay, so let's do what's inside parentheses first to find our answer. The square root of 4 is 2, but we have to cube that because that was our exponent. So 2 cubed, 2 times 2 is 4, times 2 would give you 8. So that's the reason why you want to put that exponent on the outside, is because if you didn't, you would have to do 4 cubed first and then take the square root of that number. So you get into larger numbers if you're doing that. But you can still do it if you want. Okay, so notice 8 that our exponent is negative. Anytime you have a rational exponent that's negative, that means you're going to have a fraction for your answer. Okay? We talked about Unit 8 that we can't evaluate with a negative exponent. So we want to make it a positive. So we went over that in Unit 8. We're going to take the base with that negative exponent and we'll move it. Notice that there's nothing left on top, so I'm going to have a 1. Now I'm going to have 9 to the positive 1/2 power, because when I move that base and exponent, it makes it the opposite sign. So in this case, it would make it positive. Okay, so we're going to have a 1. Now I need to change this rational exponent to a radical. Remember, we talked about anything to the 1/2 power means you're taking the square root. So our base is 9, so that goes under. Since the exponent's 1, I don't have to write that. And then I don't have to write that 2 either, but if you wanted, you could. That's the square root. So you should know the square root of 9 equals 3. If you don't, use factor tree. Find your pairs. So the answer would be 1/3. So anytime your base has a negative exponent and you're evaluating, you're going to end up with a fraction for your answer. All right, let's look at 9. So our base is 8, so that's the radicand, which is the term under the radical. Exponent is 2, and then your index is 3. So you're first going to start out with taking the cube root of 8, which you should know is 2. And then we have to square it, so that would give us 4. So 8 to the 2/3 power would equal 4. All right, 10, notice it's a negative exponent, so we're going to have to make that positive first, so we know we'll have a fraction. We're going to take the base and negative exponent and move it. So I have a 1 on top over 32. Now that becomes 3/5 as your exponent. So now I'm going to change that to a radical. So the base is 32, so that's the term that goes under the radical. Exponent is 3. The 5 is your index, so you're taking the 5th root of 32. Now, if you don't know it, those other ones were really easy. If you don't know the 5th root of 32, we're not using a calculator, so use factor tree. So 2 times 16, 2 times 8, 2 times 4, and 2 times 2. We're trying to find this number of the same, or 5 of the same number, because that's our index. So notice we can group 1, 2, 3, 4, 5, all of those 2's, which would mean it's perfect. We don't have anything left. So the 5th root of 32 equals 2, but we have to cube it. So 2 cubed would give us 2 times 2 is 4, times 2 gives you 8. So 1/8 would be your answer. All right, so that's evaluating with rational exponents. Now on the back, we're going to be using laws of exponents, which you did in Unit 8, laws of exponents to simplify each expression. Okay. All right, 11. Notice the 5's here. We talked about it in Unit 8. We have bases and we have coefficients. There's a difference. So notice that these 5s are bases. The bases never change, so it's still going to be a 5. I don't multiply the 5s together. When bases are the same and we're multiplying, remember you add the exponents. So I'm just going to write that step, 3/4 plus 1/4. When you're adding fractions, you have to have a common denominator. Notice they're both 4s, so we have that. When you're adding fractions, you're only adding the numerators and keeping the denominator the same. So 3 plus 1 would give us 4/4, which equals 1. So we would have 5 to the positive 1 power, which would equal 5. So go ahead and use laws of exponents at the beginning, and then you can rewrite it as a radical if needed to evaluate. But on this one, we didn't have to do that. Okay, so looking at 12, we're going to distribute this exponent on the inside. So we have a power raised to a power, which will multiply the powers. So I'm just going to write the step. We have 1/2 times 6/1. And then we have 2/3 times 6/1. We multiply tops, multiply bottoms, so we're going to end up getting a to the 6/2 power, b, that would be 12/3. So I can divide those. That would be a to the 3rd power and b to the 4th power. So you're having to deal with fractions, adding, have to have a common denominator, only add the numerators. Multiplying, we're multiplying numerators, multiplying denominators. So top times top, bottom times bottom. Alright, now looking at 13. Notice on this one, 27 is a coefficient, so do not forget to raise that coefficient to that exponent on the outside. So we need to have 27 to the 1/3 power, and then we're distributing, so we're multiplying those exponents. So C, that would be 6/1 times 1/3. D would be -3/1 times 1/3. Okay, so notice my base is a number here raised to a rational exponent, which is also a number. If your base is a number, you need to evaluate. So I'm going to take the cube root of 27, because remember, 1/2 means square root, 1/3 means cube root, 1/4 means 4th root, because that exponent is a 1. Alright, so we're going to get 6/3, and then we're going to get -3/3. Cube root of 27, if you don't know it, use factor tree. The cube root of 27 is 3, because 3 times 3 times 3 gives you 27. Then we're going to have c squared, because 6 divided by 3 is 2. And then we'll have d to the -1. We don't want any negative exponents, so we're taking the base that has that negative exponent and we're moving it. So notice this d we would have to move to the bottom. So on top, we would have 3c squared over d to the +1, but I don't have to write that 1. So that would be my answer there. So make sure if your base is a number that you evaluate it. So you actually need to find what it equals. Okay, so 14, we're going to distribute that 8 is a coefficient, so we need to do 8 to the 2/3, and then we'll multiply the exponent. So that'd be 12/1 times 2/3. Be 27 to the 2/3, and then b 9/1 times 2/3. Okay, so notice that we have a base that's a number here, so we're going to change this part and this part to a radical. So the 8 is the base, so that's the radicand. 2 is your exponent, I'll put it on the outside. And then 3 is your index, so that will be cube root of 8, and then we'll square it. Same thing on the 27, since it has the same exponent. We'll put the 27 under the radical. Exponent is 2, and index is 3. All right, so on top, our A, if we multiply, we're going to get 12 times 2 is 24 over 3. And then the B on the bottom, we'll get 18 over 3. So I'm going to evaluate this part. So cube root of 8 is 2, but we have to square it, so that's going to give us 4. A, 24 divided by 3 is 8. Cube root of 27 is 3, but we have to square it, so that's going to give us 9. And then we would have B, 18 divided by 3 is going to give us 6. Notice that A and B are different bases, so we can't divide them. So that would be our final answer. So again, if you have a number as your base, make sure that you evaluate it. See what it equals. All right, 15. Notice on this one we're multiplying. 5 and 2 are not bases, they're coefficients. So we need to multiply them together. That's going to give us 10. When we multiply the x's, we're going to add the exponents. So I'm going to have x, that'd be negative 2/3 plus 1/3. And then same thing on the y's, we'll add those exponents, 2/3 plus a negative 1/3. So remember we went over at the top, adding fractions, we're just adding the numerators if we have a common denominator, and we do. So that's negative 2 plus 1 is a negative, let me write my x. So that's going to be x to the negative 1/3. And then y, 2 plus a negative 1 gives you a positive 1 over 3. Okay, so notice we have a negative exponent. We don't want any negative exponents in our answer. So I'm only going to take the base that has the negative exponent. Notice 10 is not part of that base, only x. So that's the only thing that I would move to the bottom. So on top I would still have 10y to the 1/3 over x to the 1/3. Now, look at your rational exponents. You could rewrite those. Remember, 1/3 exponent means you're taking the cube root. We can't actually evaluate our base that is a variable. So you can leave it in that form, or you can do 10 cube root of y over cube root of x. So I'll accept either answers on that. Since we can't evaluate because our base is a variable, you can leave it with the rational exponent, or you can write it as a radical. Okay, so notice on 16 we have x's that we're multiplying together. Bases are the same, so our base is x. When we multiply, we add the exponents. So I'm going to put negative 1/5 plus 2/5 plus a negative 3/5. We're just adding all those exponents because all of those bases are the same. I'm going to add the first two. Negative 1 plus 2, we get 1 over 5. And then I'm adding a negative 3 over 5 because I'm just bringing that one down. That would give us negative 2 over 5. So I would have x to the negative 2/5 power. Notice we have a negative exponent. I want to make that positive, so I would take the base and the exponent and move it. Notice there's nothing left when we move it, so we have 1 over x to the positive 2/5 power. Again, you can rewrite it as a radical there, or leave it since we can't evaluate an x there. All right, last one. Negative 3 and 6, those are coefficients, so we need to see if we can reduce them. That's negative 1 over 2. Make sure you don't take the negative 3 and move it to the bottom, because that's not a negative exponent. That is a negative coefficient. Then notice that we have bases that are the same that are a's. When we have bases that are the same, we subtract the exponents. So I'm going to do 2 minus 8. That would give me a negative 6 over 7. Remember we talked about whenever you're subtracting, you need to put your answer where the larger one is, so that way you'll have a positive exponent. So notice 8 is larger, so I would need to put a, excuse me, to the 6/7 power there. And far as you can go. Excuse me. You, again, could change that to the 7th root of a to the 6th power, but you're not going to be able to evaluate that, so you can leave it as is. So that is rational, using rational exponents to evaluate